All right, today we're looking at linear relationships, so lines, and our focus is really on graphing lines. So first I'm just starting off with this concept of slope. So slope we think of as the rise over the run. So any vertical change divided by any horizontal change. So we use this little notation right here, this little delta y, delta x, that just reads as change in y over the change in x, that vertical change over the horizontal. So right here is a formula that we often use in Algebra 1, where we just show you y2 minus y1 over x2 minus x1. But really, the order could flip. I could write that this way instead, y1 minus y2 over x1 minus x2. So I could flip it, that's fine, but I just have to be really consistent when I'm pulling from one point to the other. So I want to make sure that I maintain that directionality. Okay, next I'm giving you a visual representation of slope. So here I'm giving you a positive slope because when I'm reading it from left to right, my y values are increasing. The y values are getting bigger. Let me write that. So y values are increasing. So from going left to right, the y values are getting bigger. They are increasing. Okay, an example of a line with a positive slope would be something like y equals 2x plus 1. That would be a line that has a positive slope. This is slope-intercept form. The slope would be a positive 2. Okay, a negative slope, my y values are decreasing. So when I read it from left to right, the y values are getting smaller. So y values are decreasing. And to give you an example of that, I could say y equals negative 1/2 x plus 3, for example. So again, just giving you an example of a negative slope. It's not matching my model at all. I'm just trying to give you a visualization and an equation where the slope would be negative. So here I gave you a positive slope, the y values were increasing. Here a negative slope, the y values are decreasing. Okay, a slope of 0 always reads as a horizontal line. And a horizontal line will always be y equals a constant. Y equals 7, y equals 12, y equals 0. Those would all be horizontal lines. So when we're calculating the slope, we usually think of it as a variable m. Our slope, if I had picked 2 points on this line, say I picked any 2 points, say I picked those 2 points, I'm thinking of my rise over my run. So I'm picturing my vertical change over my horizontal change. So I should see that with my y values, I don't have a change, right? It would be the same value. So it would be a number minus itself. I would have 0 on the top. So 0 on the top. And on the bottom, I would have some span between them, the horizontal change. And whenever I have 0 on the top, that's going to simplify to be just 0. So any horizontal line will always give us a slope of 0. It's saying that there is 0 vertical change, but there's a lot of horizontal change. So there's 0 rise, but there's a lot of run, and that will simplify to be 0. Okay, a slope that's undefined is always a vertical line. And a vertical line will always be x equals a constant. So it could be x equals negative 6, x equals 0, x equals 27. All of those would work. And again, if I'm going after the slope, let's say that I picked any 2 points. M equals. So on top, I would have a number, right? Whatever that vertical span is, I would have a number. right? That's my vertical change, that's my rise. But on the bottom, I have no horizontal change, right? There's 0 run, like that. So whenever I have 0 on the bottom of a fraction, that is undefined. I can't multiply 0 by any other number and produce the number that is on top. So here we say that is undefined. Just leave it abbreviated just like that. So a horizontal line will always have a slope of 0, and a vertical line will always have a slope that's undefined. All right, so now a few more examples. So first I'm looking at horizontal versus vertical lines. And up here I'm just reminding you that for a horizontal line, y equals a constant. And I'm seeing that right here. Y equals -5. So for all values of x, the y value is staying constant at -5. So if I look at, well, where is y -5? So here's 1, 2, 3, 4, 5. Well, here's y equals -5. And y is -5 here, and here, and here. All of these positions. It doesn't even have to be the integer values. The space in between would be all places where the y value is -5. So for all values of x, the y is staying constant at -5. So I can make a line right there. So a horizontal line at y equals -5. And I just want to remind you that for a horizontal line, the slope is 0. You have 0 rise, you have 0 vertical change, but you got a whole lot of run. So our slope here would be 0. I'm going to write it just to remind you. All right, vertical line next. So a vertical line here, x equals a constant. So here my example, I'm saying x equals 4. So that's saying that for all values of y, the x values are staying constant at 4. Well, where is x equal 4? Well, let's see. 1, 2, 3, 4. X is 4 here, but x is 4 here too. Also here, here, even in between all of those spaces. So I can connect all those dots and draw a line that slices through them, because in all of those places, the x value is staying constant at 4 for all values of y. Okay, and whenever we have a vertical line, our slope is undefined. So I just want to remind you of that. Slope is undefined. We have a whole lot of rise, but we have 0 run. And whenever we have 0 on the bottom of a fraction, right, that is undefined. All right, next up. So here I have point-slope form. So if I write that format underneath, you have it right here as well. I'm looking at y minus y1 equals m times x minus x1. So there's my format for point-slope, and I have that right here as well. So when we have point-slope, that means that they're giving us one point that the line passes through, along with the slope. So the point that it passes through is going to be -5, +3. It is the opposite of what it appears. So -5, +3. If I took a -5 and I plugged it right back in here, this would read as x minus -5. And when I subtract a negative, it goes to a positive. And if I just plug in a 3 right here, it reads as y minus 3. So the point is the opposite sign of what it appears. Okay, and then the slope, the m, the slope is right here at 1/4. So I want to plot a point at -5, 3. So 1, 2, 3, 4, 5, and up 1, 2, 3. I drop my anchor right there. And then my slope is 1/4. So my rise, I'm going up 1, and my run is 4. I'm going right, 1, 2, 3, 4. Up 1, right, 1, 2, 3, 4. And then I can connect my dots. And what's important to note is that any point, any coordinate along this line makes this statement true. So if I picked any point on this line and I plugged it right back into this equation, I should get a nice balanced value on each side. All right, next up I have slope-intercept form. Usually this is what everyone's favorite is. It's what we emphasize in Algebra 1 a whole lot. So slope-intercept form is y equals mx plus b. Let me write it underneath. Y equals mx plus b. So the b is also a point. It's the y-intercept. So it's going to be 0, comma, whatever the b is. So 0, comma 7. So it gives us that point to build off of. And then our slope is that m right here, the negative 3. Okay, and then to graph that, sometimes it helps to visualize that as over 1. Okay, so I'm going to drop my anchor at 0, 7. So my y-intercept, 1, 2, 3, 4, 5, 6, 7, right here. And then my slope is negative 3 over 1. So whenever I write, say I just wrote 5 over 1, right? It helps to visualize it as a fraction. So here, since it's negative, I'm going down 3, 1, 2, 3, and then right 1. Down 3, 1, 2, 3, right 1, just like that. So my rise over my run, I'm always, if it's a positive number, I'm going up and then to the right. And if it's a negative number, I'm going down and to the right. Let me connect my dots. Okay, and then there is my line. And any point on that line will make this a true statement. All right, next up, x and y intercepts. All right, so here I just wanted to make sure that we could recognize them. So here I know that this is my x-axis and this is my y-axis. So that means that right here, this location is my x-intercept, okay, because that's where my line intercepts, crosses, slices through the x-axis. And then here would be my y-intercept, right? That's where my line crosses the y-axis. So my x-intercept as a point here would be negative 2, 0. I'm always looking for the x value when the y value is 0. So for the x-intercept, the y value is always 0. And then for the y-intercept, I'm doing just the opposite. I'm looking at x equals 0. What is the y value when x equals 0? So here, if I count that up, I'm 1, 2, 3, 4, and then here's 5. So this point would be at 0, 5. So we always like to see these as points as an ordered pair. So my x-intercept, negative 2, 0. My y-intercept, 0, 5. Okay, standard form makes it really easy to graph using the intercepts. So that's why I put it here in my lecture. So if I'm looking for my x-intercept, I know that that's when y equals 0. And my y-intercept is when x equals 0. So standard form, we always have the two variables on one side and the constant on the other. And we also don't have any fractions. So the fractions would have been cleared. Let me just write a little note. No fractions when it's in standard form. Okay, so here if I'm looking for my x-intercept, that's when y is 0. So if I plugged in a 0 here for the y, this whole part here would clear to 0 because anything times 0 is 0. So I'm left with this right here. I'm using this little cover-up method. So 3x is equal to negative 18. So if I divide each side by 3, I get negative 6. So x equals negative 6. Let me just say that one more time. My x-intercept is when y is 0. If I plug in a 0 for the y, this whole part clears to 0. I'm going to cover that up. So 3x equals negative 18. Divide each side by 3. X is negative 6. So as a point, that would be negative 6, 0. Okay, my y-intercept is when x equals 0. So if I plug in a 0 here for x, right, that whole part clears to 0. So now I have negative 2y equals negative 18. So if I divide each side by a negative 2, I'm going to get that y equals 9. So as a point, that would be 0, 9. So I'm going to plot both of those points, negative 6, 0. So here's 1, 2, 3, 4, 5, 6. And then 0, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can just plot those two intercepts and then connect my dots, and I have my line. Okay, last two, just going over parallel versus perpendicular. So for parallel, here, I'm saying write the equation of the two lines graphed in slope-intercept form. So if I look at this one right here, I can see that my rise is 1 unit and my run is 4. So I could say, well, y equals 1 over 4x, and my y-intercept 1, 2, 3, 4, 5, 6, 7. So y equals 1/4 x plus 7 would be my top line in slope-intercept form, which is the y equals mx plus b. Okay, down here I can see, oh, my slope is the same. So up 1 and right 1, 2, 3, 4. So y equals 1/4 x, and the y-intercept is at negative 2, so minus 2. So here what I want you to notice with the parallel lines is that they have the same slope. They have different y-intercepts, but they have the same slope. So I'm going to add that. So parallel, oops, let me spell that correctly. Lost my R. All right, parallel lines have the same slope. So parallel lines always have the same slope. And sometimes you see these little hockey sticks, and that's a notation that we use for parallel. So parallel lines, they never cross, they never intersect because they have the same slope. All right, so then I'm having you do the same thing for the perpendiculars. First, just write the equations. So if I look at this one right here, my slope, I'm going down 1 and right 1, 2, 3. So here I have y equals down 1, right 3, so negative 1/3 x, and then the y-intercept 1, 2, 3, 4, and 5, so minus 5. So there's my equation of this line right here. And then I want this one also. So here my slope, I'm going from point to point. I'm going up 1, 2, 3, and right 1. So y equals 3x. And the y-intercept, 1, 2, 3, 4, and 5. Okay, let me just make sure I did that right. 1, 2, 3, 4, and 5. Okay, that looks good. So I have my two slopes, and I can see that this one is a negative 1/3. This one is a positive 3. So what we should recognize then with our slopes is that they are opposite reciprocals. So whenever I have perpendicular lines, their slopes will always be opposite reciprocals. And I can see that right here, that's a right angle. So these two lines, they're crossing right here at this point, and I can see that their slopes are opposite reciprocals, which makes that right angle right there. So perpendicular lines have slopes that are opposite reciprocals. Okay, and then, let me slide that over. And then all that means when I say opposite reciprocals means that they're the opposite sign. One is positive, one is negative, and the fraction is flipped. So a reciprocal just means you take that fraction and you flip it. So if I had 4/5, its reciprocal would be 5/4, for example. All right, that's all I have for today. I hope you guys have a good rest of your day.